Hi everybody, Darren here. We're at the Camosun Pipe Trades Cross Connection Lab again, and we're testing the double check valve assembly today. After I notify, identify, inspect, and observe, and ask for permission to shut off water, we've identified our gauge via serial number and verified that with our previous test forms. So first thing I'm going to do is flush the gauge, open and close each test valve to clear any debris from when it's been in service. Once we have those clean, I'm going to attach our bleed valve assembly that we have here to test valve 2. Getting ready to verify the number 1 check valve here for tightness and the direction of flow. Attach the short vertical tube that we use here in the shop. We've just got a little one to bring a water level up to that height. And I'm going to fill that tube right away. Okay, so once that's full to the top of the tube, we can attach our high side hose to the bleed valve assembly that's on test valve 2. And using our differential 5-valve differential gauge here, we're going to make sure all our control valves are closed and bleed valves. Going to open up test valve 2 slowly and bleed the gauge through the high side bleed. Just getting all the air out. Once we're satisfied we've bled the gauge, we can close the high side bleed valve. A little wipe down of the assembly and make sure we've got everything closed that should be and everything's tight. And now we need to isolate the assembly, so we're going to close number 2 shut off first, then number 1 shut off, and we're going to slowly open test valve 3 as we watch the differential gauge drop, and we can see what the number 1 check valve is holding back in the direction of flow for tightness. So got a static gauge reading here of about 1.9 psid, and again we're going to wait for about a 2-minute steady gauge reading here. If there's any change to the gauge reading, then we should start timing for another 2 minutes. So for expedience in my demonstration, we're going to say this has been 2 minutes, and I think I would actually record 1.8 psid as the static pressure drop across the first check. So we'll record that on our test form. Double check valve assembly, 1.8 psid, check valve 1, that's closed tight. Minimum requirement is 1 pound. So now we're going to close our test valves and move the equipment down to test valves 3 and 4. So I'm going to move the short water tube down to test valve 4. Can move the bleed valve with the high side hose attached down to test valve 3. Make sure that's snug on there. Again, just double check all my valve positions here. I'm going to recharge the assembly by opening up test valve 1 only. Sorry, shut off 1 only, so that I can bleed the gauge and fill the water tube. So let's fill the tube that's attached to test valve 4. Once we've got that full, I can open up test valve 3. Flush the gauge through the high side bleed. Once that's bled, close the high side bleed valve, and then isolate the assembly again by closing shut off number 1. So bled the gauge, we have the water tube full at test valve 4. Now we're going to verify the second check valve for tightness in the direction of flow. So now I do that by opening up test valve 4, allowing all the static pressure behind the second check out of the test valve, and we can see now, again, our gauge is within a gauge width of the height of that tube so that our head pressure is accurate. And similar to the first check valve, we've got a static pressure reading here of about 1.7 psid. So to be accurate, again, we're going to want to take a 2-minute steady reading. And if we didn't see any change to the gauge within 2 minutes, we could accurately say that check valve 2 is tight at 1.7 psid. So I'll record that on my form. Check valve 2, tight, 1.7 psid. And I'm going to remove the equipment from test valves 3 and 4. We're finished with our water tube and our bleed valve. Bleed valve is for troubleshooting leaky shutoff number 1. If we're doing a confirmation test on the assembly, that can be done at this time. Using just a bypass hose, we can attach to test valves 1 and 3 to verify the check valve 1 is tight versus back pressure. So we're just going to take upstream pressure, put it against check valve 1 in reverse flow. We do that by opening test valves 1 and 3 to allow water in between the check valves. Still got our shutoffs closed, and we're going to open up test valve 2. And again, the premise is if we see continuous water discharging from test valve 2, then we would know that the second check is not able to hold against back pressure. So then I can close all those test valves and move my bypass hose down to test valve 4 and repeat the same procedure. Open test valves 1 and 4. And then by opening test valve 3, there shouldn't be a continuous flow. So we know this is our confirmation test. When required, we can say that we also have check valves 1 and 2 tight versus reverse flow. So now I'm going to take the static line pressure to complete the test of the double check valve assembly. I move my high side hose down to test valve 1. Slowly open shutoff 1. Leave shutoff 2 closed. Again, check that all my valves are closed here on the gauge. Open up test valve 1. Slowly bleed the gauge through the high side bleed. And we record the static line pressure, 42 psig at the time of test. Once I'm satisfied with the line pressure reading, I can remove all equipment. It's an opportunity now to verify I have everything closed tight and wipe down the assembly. There we go. And before I put the valve back into service, ask for permission to turn the water back on and very slowly introduce water back to the system. So that's the completion of our double check valve assembly.